Augies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today's question comes to us from KH60. Okay, his name is Jeff, and he is out in California apparently. He says, this is a very interesting question. I have various sizes of solar panels, as do we all, and a wind charger. For example, one panel, that's a solar panel, has a rating of only 15 watts, which is not a very big solar panel. And another has a rating of 70 watts, which is bigger. Can I lead them all to a single controller with a rating larger than all sources combined? Surprisingly, it turns out that the answer to that is yes, but. Okay. Now, if not, then can multiple controllers be fed to a single battery simultaneously? I would not do that, and I'll tell you why. Let's take a look on the whiteboard. Solar panels, the usual way of looking at it is this. They are current devices. They generate current. Yes, there's a voltage generated across it, but if you look at the curve for this, from zero it comes up like this and then holds out pretty steady in steady sunlight. So this can be a low voltage, this can be a high voltage, and you get the same amount of current. Okay? This gives you a lot of flexibility in combining these. No, you don't combine them in serial, but you can combine them in parallel. I'll take a solar panel here. I have a 50 watt. I have a couple of 30 watts. Okay? Now, here's negative, here's positive. Okay? Positive, negative, positive, negative. There's two kinds of things you measure. Open circuit voltage. For a 12 volt panel that runs about 18 volts. And then closed circuit, meaning shorted, current, which will depend on the particular thing that you have here. It can be several amps. Let's just say 3 amps, something like that. And then this one will have a lower current. What you do is you connect these in parallel, like this, here, and then this goes to the battery controller. And what this does is each one adds some current. Okay, now here's an assumption. All of these are 12 volt panels. 12, 12, 12. Okay? Now, if you make the mistake and one of these is a 24 volt panel, I have a 24 volt panel, and the battery controller converts the 24 in, which actually goes as high as about 36, to the necessary charging current at 14.6 volts for a lithium iron phosphate battery. You want to keep your batteries, the voltage is about the same, 12 volts. My 12 volt, my 50 watt happens to be a 12 volt. Okay, so they go together, the current adds, and depending on what you're charging with the battery controller, this thing has plenty of current here, and it will either do the standard lithium or it can do the lead acid, which starts out with a bulk flow. There's the bulk charge, and this is the amount of the voltage goes up, and then it holds steady for a while. This is called the absorption, so this is bulk, absorption, and then it drops down to 13.6 volts, which we often call the trickle charge. Okay, the charging lead acid batteries is more complex than lithium ion. Lithium ion batteries are, under the covers, more complex, but there's a battery management system in the top of each one of these batteries that you can use for this. Now, you don't connect these in series because you would be getting as much current as the smallest battery can put out. The other panels will block any more current than that. You can put them in series parallel if you're trying to get a higher voltage. If you have, say, 4 30-watt batteries, you can connect them all in series. It'll still be 30 watts, but it'll be 48 volts. Make sure you have the correct battery controller for that. Now, I want to point out something from a safety point of view. The highest voltage that it is considered safe to touch, not that I'd go out of my way to do it, 30 volts DC. Any higher than that, and you can start getting a shock out of it. A 24 volt battery will go up to 36 volts. So at that point, you want to be careful. Now, if you're dealing with 12 volt panels, you're dealing with about 18 volts here, okay? And that's okay to deal with. But these 24 volt panels, you want to make sure they're well insulated, everything's well connected, and so on, okay? Now, the amount of current put out by a solar panel, I showed this curve earlier. If this is for full sunlight and you have half clouds, you'll get half of that voltage. The amount of light goes down, you get less voltage. And again, it stays pretty steady across this wide range of voltages. And I misspoke here. It should be current. So current is a fairly linear function. Here's current, and here's the percent sunlight. The current goes up, and it's a direct reader of the amount of sunlight that you have. Now, it's interesting to note, if you go over here, the current is going to drop, the voltage is going to drop. There's going to be a point over here where the current times the voltage, which equals the watts, is highest. This is the maximum power point. Okay, and it is possible to get to controllers that will deliberately find that spot so that they can put the maximum number of watts into your battery. It's quite common for that. I wrote an article some time back about solar panels and charging 12 volt lead acid batteries. That is in this QST right here, which is April 1996. Okay, so 30 years ago. Now, solar panels have changed a little bit, but what has really changed is the batteries. Batteries have changed enormously. Solar power for your ham station, it's easier than you think. And that one panel down there, which is an Arco 30 watt panel, produces enough electricity if you store it in a battery to basically run your station as much as you want. And that thing will keep it charged. So you can run it overnight, everything like that. I am set up right now with a 24 volt solar panel right the side of that wall. And it comes into a charge controller up here, which controls the charge for a lithium-ion battery. And then that runs down here underneath. I have a 100 amp hour lithium-ion battery. And that is what powers my station and does an excellent job of it. I've got all the necessary controls up there, like this right here is the charging current and so on. So I can see what is going on with that panel. I do recommend solar power, but I recommend reading about it, learning about it before you really dive in, okay? Because it is possible to ruin a battery. The thing about batteries is that they can become very nasty if things don't go well. Lead acid batteries will outgas hydrogen, which is flammable. And so you kind of want to be careful of those. There are sealed lead acid batteries. Then there are the lithium-ion batteries, which these days are better. There's been a lot of talk about those bursting into flame. You want to make sure that you never breach one of these. Don't hammer a nail into it. Don't drop it and crack it open, and so on. If you do that, get it outside immediately, because it can spontaneously combust. So if you're careful with them, you're okay. Now, I want to show you just a little safety thing that I use with mine. Now, my wires, I've got a charge controller here, and it has a wire that comes down here and connects here, and a wire that comes down here and connects here. Now for the load, I have a wire that comes down here and connects here, and that is grounded, by the way. And I have another wire that comes over here and connects here. Now why do I do it that way? What some people will do is they'll just put the load here, the battery charger here, or the charge controller here, and then come off of this to the battery. Why don't you want to do that? You have a single point failure right here. If you have a single point failure, the full output of this will go to your radios. Here I have the charge controller connected separately to the battery. Two separate little lugs here. So if this lug comes off, then this and this are disconnected. There's nothing holding them together. Okay? And that way you won't have the problem of the single point of failure, which would cause your battery to drop out of the system, and you'd have the charge controller feeding the load directly, and you don't want to do that. The battery is the great stabilizer here, okay? So that's why I make those connections the way I do. By the way, there should be a fairly large fuse right there. Okay, there should also be a fuse here, okay? And note that that's set up so that you can't get current flowing through both of those if one of those fuses breaks. So, just a little thought. So, there you have it. Until we next meet, 73.